Okay, year 10, we're going to go over the next exercise, which is solving simultaneous equations using elimination. Now, we did this last year in year 9, and to me this is my preferred method when we're dealing with linear equations. There is another method called substitution, which they did first in the textbook. They did it in 5i, but because I prefer this method, I'm going to show you it first. You can choose when you do it on your own in an exam which method you're going to use, but I think for linear equations this is just so easy when you watch how it works out. So here's exercise 5J, and I've asked you to do questions 4A, 5A and 6A. So what I'm going to do is I'm going to do 4B, 5B and 6B. You can sign off or pause the video, go and try 4A, 5A, 6A, and then come back to the video because I will then do 4A, 5A, and 6A. So I'm doing 4B, 5B, and 6B to help you through these. So here we go. Now, elimination just means eliminating one of these variables, but you need to set the work out in a manner that is logical and neat and easy to follow. So here's 4B. And we did this last year, so you should be fine. So we've got two equations. We know they're linear equations. And remember, all linear equations, all straight lines, will have one solution, no solutions, and they'll have no solutions if the lines are parallel. So you get two straight lines. Eventually, they will meet at one point. And these are linear equations. Unless, of course, the two lines are parallel, in which case you'll get no solutions. The other option is you might get two lines that are actually the same equation, in which case they're the same line, they're just written a little bit differently. So you might get an equation that is y equals 2x minus 1, and you might get an equation that is 4x minus 2y equals 2. Now they're the same equation. They are the same equation. So when you solve them, you get an infinite amount of solutions. How do I know they're the same equation? Well, let's take that 2y over the other side, and I get 4x equals 2y plus 2. Let's subtract the 2, and I get 4x minus 2 equals 2y. And I'll divide everything by 2, and I'll get 2x minus 1 equals y. So you can have what appears to be two equations. They're actually the same equation. You just have to do some algebraic manipulation. So let's go back here to 4b. And what we have this linear equation. So I have these two equations, x plus y equals 5, and 3x minus y equals 3. Now, I've put the steps to these on our web page and in the learning intentions. So, and it's a pretty cool way to remember what you're doing. Come on. So, if we go down here, we're still doing linear. Gradient, HSC, come on, more HSC. Righto. So here they are. First of all, here are our steps. I can write down the two equations. I can rewrite both equations with the same coefficients of one variable. That's what I'm going to do in a minute. I can add the two equations if the signs of the coefficient are opposite, so if one's positive and one's negative, or if the signs of the coefficient are the same, I subtract and that'll eliminate. I can solve the resultant equation, I can substitute the solution to find the second variable, and then I can check my answer. So let's go back. So I'm looking here, and remember, there's a 1 in front of there, there's a 1 in front of there, and there's a 1 in front of there. So I've written the two equations, and the first thing one of the things I have to do is I have to number them. I'm going to call that equation number 1. I'm going to call that equation number 2. Now, look at the y's. The y's have the same value coefficient. They both have a 1. So if I look back here, I can rewrite both equations with the same coefficients of one variable. I don't need to. I don't need to change either of these equations. They've already got the same coefficient in front of the y. And step 3, if the signs of the coefficient are opposite. Well, yes, I've got a plus 1y and a minus 1y. So I add these two equations, and that's what I'm going to do. So I'm going to go equation number 1 plus equation number 2. And because I've set them up right above each other, the addition of these two things is quite easy. So I'm going to go 1x plus 3x gives me 4x. 1y plus negative y eliminates. The y's eliminate. They eliminate each other. They go when I add them. I'm just going to get rid of that because it's not really mathematically correct to do that. Now I add the two values on the other side. 5 plus 3 is 8. Now it's a really easy equation to solve. I divide by the 4 and I get x equals 2. And that is step number 4. I can solve the equation that I get out. So what have I done? I've taken two equations with two variables to give me one equation with one variable, and I solve that. Now, the next step, I can substitute the solution into one of the first equations to find the second variable. Well, we've found x. We have to find y. I've got a choice. I can sub it into equation number 1, or I can sub it into equation number 2. I'm going with equation number 1 because there are no negatives, and I don't want to take the risk of making a mistake. So I'm going to sub that x equals 2 into equation number 1. And when I do that, I get, I put the 2 in for the x, plus y equals 5. And this is a really easy equation to solve. I subtract the 2, and I get y equals 3. So now I've got a solution, and it's a coordinate. It's a coordinate 2, 3. And it's going to be the point where these two equations intersect. 2, 3. Now, how do I know I'm right? I check in equation number 2. So I put these two values, x and y, into equation number 2 and see if it works. And equation number 2 is 3x minus y equals 3. So 3 times the x value, 2, minus y, 3. Well, what does that equal? 6 minus 3 equals 3. And was that what we needed? Yes, it was. So it works. It's true. And my solution is correct. And the solution is the coordinates 2, 3. Now that is 4b. That should be enough for you to do 4a. All right. I want to do one where the signs are the same. So I'm going to do 4e as well. I said I'd do 5b, but I want to do one where the signs are the same. So I'm going to do 4e, just so you can see what happens when the signs are the same. I want to do one that has an x. I'm going to do 4g, sorry. So I do one where I'm subtracting the x value. So what have we got? 2x plus 3y equals 1. 2x plus 3y equals 1. And 2x plus 5y equals minus 1. 2x plus 5y equals negative 1. I'm going to call this equation number 1. I'm going to call this equation number 2. So I've written down the two equations. Two equations with two variables. I'm looking for two of the coefficients or the coefficients of x or the coefficient y to be the same. And I look here and I see the coefficient of x is 2 and 2. So they're the same value and they're the same sign. Well, what do I do if they're the same sign? I subtract. Now here's where you've got to make a decision. If I subtract them in the order that they are, if I go equation number 1 minus equation number 2, I'm going to get 3y minus 2 minus 5y. I'd rather not do that. I'd rather simplify it. I'm going to go equation number 2 minus equation number 1. Now, I know that's a bit upside down, but it's not that hard. Now, 2x minus 2x, that eliminates. 5y minus 3y is 2y. And here you've got to keep the order. Minus 1 minus 1 is minus 2. All right, you've got to keep the same order. Make sure that whatever order you decide to subtract them in, you do it the same for both. I divide by the 2, I get y equals negative 1. I now have to make a choice. What am I going to substitute that into? Well, it doesn't matter. I'm going to sub that into equation number 1. And I'm going to get 2x plus 3 times negative 1 equals 1. 2x minus 3 equals 1. Add the 3. 2x equals 4. Divide by the 2. X equals 2. Now I've got one variable. I've got my solution. 2 and negative 1. But I may have made a mistake. It's very common. You can make a mistake quite easily. So I'm going to check. Now, because I got the x value from equation number 1, I must check in the other equation. So I'm going to check in 2. And equation number 2 was 2x plus 5y equals negative 1. So 2 times x minus plus 5 times negative 1, what does that equal? 4 minus 5 equals negative 1, which was the correct answer or the correct value. So I know my answer is right. So they're pretty easy. But in question 5, I have to do something a little different. So I'm going to do 5b. First thing, what are my two equations? On 5b, my equations are 2x plus y, 2x plus y equals 10. And the second equation is 3x minus y, 3x minus 2y equals 8. 3x minus 2y equals 8. Let's double check, make sure, because I don't want to write down the wrong equations. Yep. Okay. I call this equation number 1, and I call this equation number 2. Now I'm looking at the coefficients of each variable. I've got a 2 there and a 3 there. They're not the same. I've got a 1 there and a 2 there. None of the variables are the same. So I have to manipulate the equations. Now I can manipulate the equations because as long as I do the same thing to both sides of the equations, I can manipulate them. So what's going to be the easiest? Well, I could times this equation by 3 and this equation by 2, and that'd get me 6x and 6x, and I could eliminate those. Just think about that for a moment. If I multiply the first equation, everything by 3, my x will become 6x. And if I multiply the second equation, everything by 2, my x will become 6x, and I'll be able to eliminate the 6x. Now that'll work, but it's too much work. We only want to do as much work as we need to. If I look at the coefficients of y, if I just multiply this first equation by 2, what will happen to the y? It'll become 2y. And then I'll have the y's the same. So that's what I'm going to do. I'm going to take equation number 1, and I'm going to times it by 2. I have to multiply everything by 2. So 2 times the 2x is 4x. 2 times the y gives me 2y. And 2 times the 10 gives me 20. That's the most common mistake. People forget to multiply the constant. Now, even though this is the same equation as number 1, I'm going to label it equation number 3, because I'm now going to do something with equation number 2 and number 3. Look at my steps. I've written down the two equations. I've rewritten both equations with the same coefficients of one variable. Now, are the signs of the coefficient the same or different? I'm pretty sure they're different. So I'm going to now add these two equations. So I'm going to add equation number 2 plus equation number 3. And that will eliminate the y's. 3x plus 4x, 7x. Negative 2y plus 2y eliminates. 20 plus 8, 28. Divide by the 7 and I get x equals 4. Now I have to check, get the second variable. Now I can substitute it into equation number 3, 2 or 1. The simplest one is going to be equation number 1. So I'm going to sub this value, sub this into equation number 1. And what do I get? I get 2 times the x value, which I have is 4, plus y equals 10. That gives me 8 plus y equals 10. Subtract the 8, I get y equals 2. Now, I have a solution, a possible solution, 4 and 2. Well, I have to check it. Now, I can't check it in 1 because that's where I got it from. And I can't check it in 3 because 3 is just a different version of equation number 1. I have to check it in 2. So I'm going to check in equation number 2. And this checking procedure is important. You'll notice that I haven't gone to the answers at all, because if I check and it works, well then I know I've got the right solution. And this is what you should be doing when you do an exam. So I've got 3x minus 2y equals 8. So 3 times 4 minus 2 times 2, what does that equal? 12 minus 4, that equals 8. That is the value we wanted. We know it works, hence our answer is correct. So that's 4b. 5b. So there I only had to change one variable. If I look at equation 6b, and this is the last one I'm going to do. I said I'd do 5a, do the a's for you, but you need to have a go at them yourself. So I'm going to do 6b. And 6b is going to be a good one. Okay, what have we got? 3x plus 2y equals 5. 3x plus 2y equals 5. And 2x plus 3y equals 5. 2x plus 3y equals 5. Okay, so I've got these two equations. They look very similar. Okay, what do I want to eliminate? Well, none of the coefficients are the same. I've got a 3 and a 2 here, and a 2 and a 3 there. I could go either way. It's not hard to eliminate the x's or eliminate the y's, but I'm going to eliminate the y's. So to make the y's the same, I need to multiply that by 3, and I need to multiply that by 2. And that'll make them 6y. So I'm going to take equation number 1, I'm going to multiply it by 3, and watch what happens. I multiply everything by 3. 3 times 3x is 9x. 3 times 2y is 6y. And 3 times 5 is 15. And now that's my equation number 3. Let's do equation number 2. I'm going to multiply it by 2. So 2 times 2x is 4x. 2 times 3y is 6y. And 2 times 5 is 10. Now I'm going to call that equation number 4, but it's just a different version of equation number 2. Now, the coefficients of the y are the same. Let's go back to our steps. I can rewrite both equations with the same coefficients of one variable by multiplying one or both equations by a constant. Well, I had to multiply both equations by a different constant, one of them by 2, one of them by 3. Now, if the signs of the coefficient are opposite, I add. Well, they're not opposite, they're the same. If the signs of the coefficient are the same, I've got to subtract. Let's go back. So, which way will I do it? Well, I'm lucky the bigger x is on top, so I'm just going to go equation number 3 minus equation number 4. I could go the other way. You'll still get the correct answer, but it's just easier to do the subtraction this way. 9x minus 4x is 5x. 6y minus 6y eliminates, and 15 minus 10 is 5. Now I've got a really simple equation, and I solve it. I divide by 5, x equals 1. Now I have to substitute that, and I've got 4 equations to choose from. But just remember, equations 1 and 2 are simpler versions of equations 3 and 4. So it's going to be easier to substitute into either one of those. So there's not much difference, so I'm going to sub into equation number 1. Equation number 1 is 3x plus 2y equals 5. So 3 times 1 plus 2y equals 5. 3 plus 2y equals 5. Subtract the 3, 2y equals 2. Divide by the 2, y equals 1. So I've got a solution now, 1, 1. But I have to check. Now I've got 3 options. I can check in 2, 3, or 4. I can't check in number 1 because that's where I got it from. Well then, Mr. Tonkin, you can't check in 3 because 3 is just a different version of 1. You have to check in 2 or 4. Good point. Well, the easiest one to check is number 2 because 2 and 4 are the same equation, but 4's that equation multiplied by 2. So I'm going to check in equation number 2. So check. And you need to do this on your assignment. If you don't do this, I'll take marks away from you. So check in 2. And equation number 2 was 2x plus 3y. So 2 times 1 plus 3 times 1 equals 2 plus 3, which equals 5, which is the correct answer. So solving by elimination is pretty easy, and you need to set it out properly. First of all, realize what you're finding. You're finding where 2 lines intersect. If you solve them or you do this process and you can't get an answer, it may mean one or 2 things. The 2 lines are parallel, or the 2 lines are actually the same line. Okay, what do? Look at the 3 steps. Write the 2 equations. Look at both variables, and it might not be an x and y. It could be different letters. In most cases, in coordinate geometry, using Cartesian number plane, they will be x and y's, but sometimes they might not. So look at the 2 variables, the x and y's, in both equations. Try and see if the coefficients are the same for one variable. If they are, you're off to, and you can just, if they're the same sign, subtract. If they're opposite signs, add them. If they're not the same sign, look for the easiest thing to multiply an equation by, or both equations by, to make one of the coefficients the same. Always go for the easiest option. It may mean multiplying one equation by a constant, or it may mean multiplying both equations by a different constant. So if you look at question 6, they're ones where you have to go, I'm going to have to multiply both of them. In 5, you only have to multiply one of them. Now, I've only asked you to do 4a, 5a, and 6a, But if you think you need more, do a couple more. Don't do a hell of a lot, just do a couple more. Anyway, and then get on to the assignment. Good luck.